In this demo, we will see how to set up a DR for the application deployed on GCP GKE. Our source production cluster is deployed on in US Central 1 region, and our DR site cluster is deployed in US East 1 region. Let's look at the source and target environment. These are the two clusters created for this demo. SWIFT can perform the cross-platform, cross-version migration and the DR. But for this demo, we have created these two clusters in different locations on GKE. I have deployed Kubernetes dashboard on both the clusters. Let's look at the dashboard. And in that we can see, so I have created one Blogger namespace, and in this namespace we have deployed the app for which we are going to set up a DR. We can check that as a workload, we have one deployment and one stateful set, and the objects related to is that pod replica sets. For persistent volume claims, we have two persistent volume claims with the storage class standard. So SWIFT can perform replication, migration of non-CSI as well as CSI volumes. So for this case, we have taken non-CSI storage class for this application. Let's look at the app site. So this is our application website where I have created a sample post. So once DR is set, we will see that all the data is migrated correctly and this sample post is up and displayed on the target also. Let's look at the target environment. In target, there is no workload present, no services, and for secrets, there is only one secret I have created. This is Docker registry credential, which is required for deploying the SWIFT transient pod on the target cluster. This is also created on source cluster also. So this is part of prerequisite. This will help us to deploy the tripod on the source and target environment, and will deploy the tripod and migrate the application. Now let's move to the migration DR, setting up the DR. Click. So we have to log into the SWIFT server. Before setting up the DR, we have to discover both the environments, so DR site cluster and the source cluster. For this, go to the container cluster and then click on add. Currently, these are the platforms supported by the SWIFTs, from where you can discover the clusters and perform the migration or the setup the DR. These are the platforms for Kubernetes, and for OpenShift also we support OCP and OKD environments from these clouds. Let's provide the details to add the cluster on the SWIFT environment. Provide the friendly name for the cluster. Then select the Google GCP, enter the cluster name on the GCP cloud, then region where it is deployed, and we will need the credential file to reach out the cluster. Tripod image and tripod secret is used to deploy the tripod. There are other options also. If you have safe deployed for your Kubernetes cluster, then you can provide the secret here. And then for tripod, you can provide the specific resources like amount of CPU and memory. Click on add, and this it will quickly discover our production demo cluster. Let's also discover the target cluster. Select Google GKE as a cloud type. Enter the details required. It is deployed in US East 1 region. This will discover the target site also. So in discover operation, Swift collects the metadata of this cluster, like the information of the cluster, like exact version, then build date, then namespaces created on this cluster. So we have this namespaces created. We are going to set up TR for the blogger namespace. So it is also displayed. The pods related to it is displayed. If you want to check other objects, then you can check it from here. Okay, now our both the source and DR site cluster is discovered. So now we can move to the next phase, that creating the storage pool. Enter the friendly name of the storage pool. So currently GFS is only supported, and in soon we will have different options also, like SAN, NAS, all these types of pools will be supported. Select the raw disk. You can add multiple disks to create the pool. Click on add. The pool is created now. Setting up TR is possible in two different ways, like create the TR policy and directly set up the DR operation. But we recommend the second approach, where we are performing the stage 1 operation. So in stage 1, it will first back up all these things to the Swift server, and in stage 2, when we set up the TR to the target TR site. So there are multiple customized options are available for these sync jobs. So you can try it from here. So go to the sync animation, click on all replications, and we have two options. You can set up a TR, migrate applications, or image registries using these two options. Click on application replication, click on stage 1. So this is the straightforward way. You can select the platform which the Kubernetes or OpenShift. So I have selected Kubernetes. Set the cluster name and the namespace from where you want to take a backup. Let me add the name of the image group. And there are two options available for migration. So all is first, and the selective. For any reason, suppose you want to migrate any specific microservice, then this can be done from here. You select the service name and select the microservice name. So you can add one or multiple microservices here, and it will back it up. So Swift will intelligently identify all the related and associated objects related to it, like the pods deployed, config map, secret, persistent volumes, persistent volume claims, all these things will be identified and will be backed up. So for this demo, I am selecting the all option. And this is related to the tripod transient pod deployment. This is a SWIFT tripod which will be deployed on the source environment. So selecting select IP type is selected as load balancer. This will create a public IP for this tripod, but we don't have to worry about it because all the communication between SWIFT and the source environment is encrypted over the wire. We have to provide the two type ports. If you select the auto select ports, then we have to open this port range in firewall. But in my case, this port range is not enabled, so I am specifying these two specific ports. SWIFT will create these. SWIFT will open these ports in firewall for us. Add the customized job name. I'm adding this as Power stage 1. There are other advanced options here like PostScript, prescript execution, YAML execution on the source environment before and after our actual sync. Then a volume sync config, excluding or including specific volume from this operation. Okay, click on add and this will create a sync job. Now the source environment backup is in progress. So here summary will display all the related details and sync progress will display all the related checkpoints to it, like mounting image, creating snapshot. All these things will be displayed here. If anything fails in between, then this will be also displayed in detail here. So user will get idea what is happening. So currently it is trying to deploy the tripod on the source environment. Let's go to the source dashboard and let's check this tripod deployment is in progress. So when all these operations are performing, like backup of the environment, then we can check the source site is not down. So there is no downtime here for this operation. Tripod is deployed successfully. Now it will start the sync operation and will copy all the data. Here it is displaying the persistent volume claims and the progress of the copy. Data copy is completed and now it is deleting the tripod. So once it is done, from source the tripod is deleted. Operation is completed successfully. Object copy is also completed. So once operation is completed, you can find all the related details here, like summary of the sync, how much data is copied, and the specific volume summary also, like for WordPress, how much data is copied and the total average speed. All these things will be available here. Now, all the data is now available on the Swift server in this our storage pool. Now let's create the stage 2 job, and it will replicate all the environment to the target DR cluster. For this, I am selecting the storage pool and our image group backup name, and then select the target cluster where you want to migrate all these things. And here you can specify the zone, in which zone you want to copy all the and replicate the environment. Also, you have the choice to set a storage clause for this newly created PVCs. So from here you can select the storage classes. Click on it, and this will start replicating the environment to the target DR site cluster. Now it is trying to deploy a tripod on the target. Let's check the persistent volume claims and persistent volumes. Persistent volume claim is created. Volumes are also ready. And now the data copy will be started. Okay, now deployment and stateful set creation is in progress now. Let's check the other objects are also migrated. So config map is created. The persistent volumes are created. Secrets are also created here. So application is ready now. Let's check that operation is completed, and we can check now the target app. So let's go to the services. We have 2 services created now. Let's open the website. Okay, on target also we can see now that sample post is available. So we can conclude that in this 2-step process, application is migrated successfully to the target DR site cluster. So now both the operations are completed successfully. We can set up a DR for this operation. So for this, we have to create a DR policy. In DR policy, click on new and select the stage 1 to operation to set up a DR. So we have multiple options available when to execute the policy. By schedule, daily, weekly. If you want to exclude the specific day, then it is also possible. By frequency, hourly, by after a few minutes, once in future, or continuously. So for this operation, I am selecting as a 15-minute policy, and let me add the name. For stage 2, also you can set the frequency. For this operation, I am executing after stage 1 operation. Enter the email address to get the detail of the operation over the mail. If you want to get the alerts for the only failed operation, then you can check this option. There are advanced options for executing the scripts and deploying the YAML also on source and target before the DR policy start and end. So click on create. Now our policy is created. You can now apply the DR policy to the application. So inside one DR policy, you can add multiple operations. That's why these are the two-step process. You can start policy as soon as the execution it is applied, or you can start it later. Now select the operations, stage 1 and stage 2 operation. And click on add. This is the fallback operation for failover. This is the configuration required for failover operation. And click on add. Click on apply, and this will apply the stage 1 policy. Here we can see for each operation you will get this information. Summary, then events created, like stage 1 is now started. So we have selected start immediately. So stage 1 is now started. And you can get associated sync job idea here. If you click on it, then you will get all the details here. This will execute a DR policy with every 15 minutes and will back up the source environment to the SWIFT server, and it will replicate to the target DR site also every 15 minutes. So this is the frequency we have selected for this policy. Stage 1 is already completed and stage 2 is started. So all the data copy is completed and it will create the target environment. So let me close it, and here we can check the tripod is completed, and it will take down the application and it will reconfigure all the objects, recreate and reconfigure all the objects from beginning. Policy triggered 2 operations. At stage 1 operation is triggered, then it completed. The stage 2 operation is already started, and data copy is completed for this operation. So currently it is verifying the health of replicated objects. So on target, we can check that, okay, all the objects are up now. Let's go to the service and we can verify that application is up. Okay, and the stage 2 is also completed. We set the TR policy execution every 15 minutes. Now let's change the source environment little bit and observe that the target environment also reflects these changes. Let me create the new sample post on this website. Go to the post, add new. I have published this and it is available. Let's wait for the next delta sync to trigger. In next sync, all the data will not be transferred from the start. Only the changes will be identified on the PVs, persistent volumes, and all these changes only transferred to the target environment. So in this case, our case, we have set stage 1. So the changes will first go to the backup, Blogger backup, and then it will be replicated to the GKE TR demo DR cluster site in stage 2 operation. DR policy operation is triggered now. Now it will identify all the data change on the source persistent volume and it will back up only that part. So now in this step, the volume data copy will be faster than previous one. Now it is verifying the status of all the objects. Let's go to the target work, check the workloads. All the objects related to are up now. Now let me open the target app site. Okay, on target also we can see that delta sync sample post is created. Now let's move to the TR policies. Due to any reason you want to pause the TR policy, then you can pause it from here. You can pause all operation or you can pause any selective operation from it. Let me pause the TR policy. TR policy is paused now. Let's if you want to resume, then check this policy and you can resume it from here. There are other options like TR failover. Suppose due to any reason your TR event happens and your source environment goes down, then you can use failover option. We can failover all the TR related operations, or you can use the selective one. There is a one drill mode. Yeah, instead of doing actual failover, you can test the failover with the DR drill mode. So let me click on the failover. It will quickly pop on the failover. If there is any change, then it will trigger related operation. Now it is failing over. Let's open the active replications. So failover is completed. Let's check state is changed to failover and related events are also created. The failover is completed. Now if you can do the fallback also. So suppose now the production site is up, then you can click on fallback and you can perform the all or selective fallback. No reversing is the option in case your production is up and you don't want to sync all the DR site changes to the source, then click on not reversing and click on fallback. It will quickly fall back to the production environment. That's all we want to show for this demo. Thank you all.